Well, what if you did it wrong, sir? But you might have. Okay, so back to what we were talking about and what Hudson discovered. Okay, so Hudson said they're both perfect squares. Well, that's not what he said, but that's what he meant, right? They're, forgot what the word was, but they're both perfect squares. So we could take the square root of this and the square root of that, because x squared is also a perfect square. It's x times x, right? So when you're factoring this, you're going to have 2x and 2x, because that's the perfect squares, right? And then you're going to have 3 and 3, because that's the perfect squares. And then, and I don't remember which person it was that thought of this a while ago, so I just don't remember. But remember, somebody said, oh, it was Landon. Landon said the inner and outer, the inside, canceled each other out. Well, that's because you have a positive and a negative. So this is called a difference of two squares. And this only works, y'all. This only works if you have a minus in the middle. If you don't have a minus in the middle, it does not work. Okay? So like if you look at number 3, that's a perfect square. That's a perfect square. There's a minus in the middle. We do have two different variables, but they're still both perfect squares, right? So to factor that, we can do x and x, 4y and 4y, 1 plus, 1 minus. And it doesn't matter which one you put the plus and which one you put the minus. It doesn't make any difference. Okay? If you look at number 7, is number 7 a difference of two squares? No. But is there something we could factor out maybe? Okay. There was some papers that may have been one of y'all's too. I didn't even notice the extra bags. Anybody else? Didn't even notice them. Okay, so we can factor out x squared, can't we? So we factor out x squared. So we've got x squared on the outside. That's going to give us 8x minus 1, right? We could do negative x squared if we wanted to, but it's not necessary. So you could, and if you did negative x squared, what would happen is you'd change all the signs. But it's a lot easier if this is not a negative out here. You're not dealing with the negative up there. Or this being a negative right here. Now, that's factored. That's as factored as that's going to get. Okay? Everybody good so far? Right, look at 8. Is 8 a difference of two squares? Are you sure? So x squared is a perfect square. And 49 is also a perfect square. But y'all look at this number. I mean, look at this sign. That's a positive, which means we would have to multiply either two negatives or two positives. Right? So if, let me grab my little scratch paper here. Hey Hudson, you paying attention to this one, buddy? This is the one I'm concerned you may have messed up on, okay? This one, number 8. So if you did two negatives, right? That's going to get you x squared and 49, but look at what your outer and inner is going to get. Negative 14x. Right? If you did two positives, you're going to get 14x. We don't have a 14x, people. Do y'all see? So this one's actually, well, okay, let's think that through. If the x's were negative, But then these would have to be both still the same sign, right? So what are we still going to wind up with? Not factorable. So this one is not, excuse me, not factorable. Now, I'm gonna take y'all on a little trip that I've not done with all my classes, okay? But I think y'all can handle it, okay? Do you have a calculator? If you don't have one, grab one and reset it for me for just a minute. Yeah, it did. Oh, you thought you just blinked. Oh, gotcha. Second plus sign. 712. The reason I'm having you reset it, because I did do it with one of my classes earlier, and some of your settings may be weird, okay? So, let's say that what I told you was I want you to solve this. And when you're solving an equation, your goal is always find the value for x. That's what your goal is, right? So it's x squared plus 49, and we would set it equal to 0 to be able to solve it. Because you have to have an equation to solve something. We didn't have an equation until we put equals 0. Now we have an equation, okay? So if we're solving this, then our first step would be subtract 49, right? So we do that to both sides. So we have x squared equals negative 49. Then you would square root it. So take the square root of negative 49. So on your calculators, take the square root of negative 49. Tell me what you get. So you got error, non-real answer. Now let's talk about why. What does square root mean?
Something times itself.
A number times itself. So if we're multiplying a number times itself, can we get negative?
No.
We can't get a negative. Because a negative times a negative and a positive times a positive. The only way to get a negative number by multiplying two numbers if you have one negative and one positive. But if you have one negative and one positive, are you multiplying something times itself? No. So it's impossible to take the square root of a negative number in real numbers. Okay? Now I'm fixing to have you make a setting change on your calculator. So on your calculator, I want you to hit the button, the mode button. So you have to turn it on if it's not on. Hit the mode button. And down almost at the bottom, do you see where it says real? Arrow over to where it says A plus BI and hit enter. So you're now putting your calculator in imaginary number mode. Okay? Now take the square root of negative 49.
7i.
And you get an answer, 7i. Now let's talk about what that means. So,
How do you get it?
I'm fixing to explain. So, because we can't take the square root of a negative number, we can break this number down, though, into 49 times negative 1. Okay? We can take the square root of 49. The square root of 49 is 7, right? The square root of negative 1 is I. I is imaginary number. So now, not only have we added variables to your math, we've added numbers that don't exist.
Why? What is the purpose? Yeah, what's the purpose?
So, real life, real everyday math, this is not something you would ever use. This is something that might be used in some more complex math. Say if you're doing some pretty complex stuff, you might have a real answer and then you might have an imaginary answer. Huh? So let me give you an example. An example that might make it make a little more sense. If I were to graph this right here, if I was going to graph that would be a parabola. That would be a parabola that opens up. Okay? That parabola that opens up has a y-intercept of 49, right? So if I were to graph this parabola, then up here at 49 is where it crosses and it opens up like this.
Oh.
That's a parabola. Now, whenever I'm solving for x in x squared plus 49, when I'm solving for x, I'm finding the locations where my parabola crosses the x-axis. That's what I'm doing. But it doesn't. So my answers are imaginary because it doesn't actually cross the x-axis. I saw that. I'm so sorry, Preston. I'm so sorry. I could not help it. I give you extreme permission to laugh at anything I ever do. Oh, Preston's lip just sprung a leak.
Why does my brain match the word parabola with the Macharoda song?
I don't know. That's weird, though.
That's what it's been doing for the past
Maybe some teacher you had used that song in the song and to make a parabola song. I have a parabola song.
What's the parabola song?
Let me see if I can remember it. No.
It's probably more like a rhyme.
No, it's a song. Like it's, yeah.
Same time.
I don't know if I remember. I'll have to hunt up my lyrics. If I read my lyrics, I would be able to remember the tune. No, it's set to like a almost a mariachi type music. I also have a solving a linear equation song too.
You know that one?
I may have that one in my drive. We can only take a couple minute detour because we got some other stuff to solve, okay? But we can take a couple minutes.
I love how everyone's gonna see what's pretty.
What?
They're just gonna see how we go.
Oh gosh, yeah, I forgot about that.
What are you thinking?
My drive, yeah. No, I don't have it in my drive. I'll have to hunt it down. I've got it somewhere. I hope not. I don't think I've ever posted it anywhere. Okay.
Yeah.
Do y'all know not one person has mentioned the merch to me? Not one person has asked about my merch.
Really?
I told you nobody watches my videos. But you could always comment on the link that I post in the classroom.
I'll do that.
Huh?
Everyone just type
Where's the merch? Okay, now, so y'all see how this imaginary number thing? This is Algebra 2 stuff that you'll get into. Technically, you should have learned it last year in Algebra 1, but I don't know a single Algebra 1 teacher who ever has time to get into it. Like, we just don't. We run out of time. Do y'all, those of you who had Miss Brackett or Miss...
Golden now.
Yeah. What is it now? Golden? Golden?
Yeah, golden.
Okay. if you had her last year, do you remember doing imaginary numbers in her
Never
class?
got to it.
My class didn't get to it either. I think I may have mentioned it to them, but at the very end of
She never
school.
mentioned
You ready? Do you remember? Oh, you went virtual though, didn't you? Eden, do you remember doing imaginary numbers? I don't think we ever got to it. We never do. Like it's just one of those things we don't get to. But next year in Algebra 2, you will use imaginary numbers, okay? So you need to have, this way you're introduced to it. Okay? Okay, so let's solve some more problems though. So look at number 4 with me. So tell me what you notice about number 4.
Two variables.
Okay, so we got 2 different variables going on there.
None of them are, what's the word?
Factorable.
Not that word.
Like terms.
That word.
None of them are like terms. Yep, that's true. That's true. Okay, so I could let y'all sit here for 20 minutes, 20 years. It's not going to make any difference. You're not going to figure this out on your own. But I can show it to you, and you're going to go, oh, it's not even hard. So what we're going to do is we're going to group these two together, and then we're going to group these two together.
That makes a lot more sense.
I remember doing this last week.
I don't.
Okay, now, once we group them together like that, we're going to ignore this side for a minute, and we're going to focus on just those two. And if you look at just those two, is there anything you notice about them?
They both got X.
They both have an X. We could factor that X out. We can't do square root only because it has an X, right? So it has an X, so we can't do square root. But we could factor X out of both of them. And if we factor X out of both of them, this is what we get. Right? Because we're factoring out X and factoring out X. Now, we're going to put that plus sign. That plus sign did not disappear. We're going to put it down here, right? And then if we look at this side, we can factor out Y, anything else? 2. So we can factor out 2 and Y, right? So both of them can be factored by 2 and by Y. So that's going to give us X.
It's X minus 4 again.
Yep. Again.
Oh, is that it? Yeah, I remember. And then you do X plus 2Y, and then on the other one, it's X minus 4.
Yes. So they both have X minus 4. So since they both have, this is one term here, this is the other term here, and they both have X minus 4, we can factor X minus 4 out of both of them. And if we do that, if we factor X minus 4 out, we have X, this plus sign, plus 2Y, and it's multiplied times X minus 4. Now, if we were solving, like if I said solve, we could not solve this. You all right, buddy?
Probably.
Okay. Raise your hand or something if you're dying, okay? Okay. We can't solve this. Why can we not solve this?
There's 2 variables.
We have 2 variables. We can't solve this. Now, if that Y was not a Y, if it was something like just a 2, we could solve. But we can't solve the way it is because we don't know what Y is. We don't have a value for Y. Okay? Everybody good? Okay. So let's look at, yes, sir.
How did you get 4 out of X minus 2xy minus
8 divided by
8 divided by 2. Mm-hmm. We were factoring out, I can't find where my problem is. We were factoring out 2y, so we divided 8 by 2, 8y by 2y.
I thought it was subtracting.
Yep. Yep. Okay, so let's look at,
number 3.
we already did number 3.
Yeah.
You were not.
What number 6? What was the answer? I think I already did. I could bring something else if I saw it.
Number 3 was x plus 4y, x minus 4y. We'll come back to number 11 in a minute, okay? Let's look at number 8. Let's look at number 18. Let's look at 18. We'll go back to 17. We'll look at 11. But right now I want us to look at 18, okay? So on 18 is very similar to the one we were just doing. We're going to group these two, and then we're going to group these two. Okay? So when you look at this first grouping, what could be factored out? X, and what does that leave us?
X squared minus y.
Okay, and then we got this plus sign. Now, if you look at this, there's nothing we can factor out. But what do you notice about it?
It's like number 3.
It is. So they both have this, y'all see? They both have x squared minus y. Does everybody see what I'm saying? That they both have that?
Understood.
So we can factor out of both terms x squared minus y. That means this term we factor out x squared minus y. And we get x. This term, if we factor out x squared minus y, this part's tricky. Most people miss this. We get 1. Good. You're the first people to get that all day. We get 1. Everybody says 0.
That doesn't make sense.
But those, when they cancel, we always say they cancel, right? But they're not going away. They just create 1, the number 1. Huh? You're dividing it by itself. That's perfect. And that's our answer. If we're factoring, right? Now, if we were solving, we would not be done. But we couldn't solve because there's a y and an x. No. Not unless you just want to do extra work for no reason. Okay, Chris, what was the first one you asked for? 11. Let's go back and look at number 11 with Chris. And I'm actually going to show y'all something I had forgotten about. I did it with my 4th hour class. The few minutes I actually got them to work today. And I had forgot about using this specific method to do some of these problems. So it's a good thing to show you. So this is in what's called standard form. Standard form is when you have x squared, x, and then a constant. And standard form looks like this. Ax squared plus bx plus c. That's called standard form. Where a is the coefficient of x squared, b is the coefficient of x, c is the coefficient of 4. This is not number 11, is it?
No,
It's fine. That was the first one Chris said, and then he said it.
Okay. Okay, now we are going to draw an X. This is actually the name of this is like diamond math or something, but I don't know why they call it that. Okay, up here we're going to put A times C. Whatever A is times whatever C is. So in this case, that's going to be 9 times 4, which is 36. Down here, we're going to put whatever B is. In this case, B is negative 12. Now, what we're looking for right here are two numbers that would multiply to get us 36, but would add or subtract to get negative 12. It's similar. We're actually going to use the box still. We're still going to use the box. I'll show you in just a second, okay?
Negative 6.
So if you had negative 6 and negative 6, that would multiply to get 36, but that adds to get negative 12, right? This and this go in your boxes. So this up here is going to be our 9x squared, right? This down here is our 4. This and this is our negative 6x and negative 6x. We just found what our outer and inner come up to. Yes. So what that does for us is it means now we know what we're getting when we multiply. Where before we were having to like guess and check like every single option, and now we can be like, oh, that's not going to work because, right? So now this could be 9 and 1, or it could be 3 and 3, right? 9x and 1x, or it could be 3x and 3x. This 6 could be 6 and 1, or it could be 3 and 2, but it's going to make it a little easier for us to check, because if I have 9, there's nothing I can multiply by to get 6. Do y'all see what I'm saying? That means I know 9 and 1 can't be an option. Now, if I multiply something by 3 to get 6, what could I multiply by 3 to get 6? I could multiply 2. And then down here, what would I multiply 3 by to get 6? 2 also. Y'all see how that works? And doesn't 2 and 2 get me 4? But I need a negative 6. What does that mean? And then I need a negative 6 here. What does that mean? So that's going to give me 3x minus 2 and 3x minus 2. And so it is 3x minus 2 squared, if you want to write it like that. Huh? It is. But the more of these that you do, the better you get at them. It's one of those things you just got to stretch your brain a little bit. Yep, we can do 11 now. Okay, so we're going to do 11. So we're going to make our x, right? Up here is going to be whatever 6 times 6 is, which is, down here, we're going to put 13. So we need two numbers that multiply that get us 36, but add or subtract to get 13. 7 and 5 is not 13. Or 36. Yeah, there is. 4 and 9. 4 and 9 is 36. 4 plus 9 is 13. So it's going to be 4 and 9. Now, these, remember, are our boxes, right? So we've got, we know this is 6x. We know this is 6. Now we know that one of them is 4x and one of them is 9x. We do not actually know which one is which, but we can throw it down. We may have to make some adjustments, but we can put it in. Okay, so this could be 6 and 1 or 2 and 3, right? Or it could be 6 here and 1 here, or it could be 2 here and 3 here. And that's an important important thing to think about. Because I could be saying, oh, I mean, if this wasn't 9, I could be like, well, 6 isn't multiply times anything to get 4, but maybe this had been like 12 over here, and it could multiply by something to get 12. Do y'all see what I'm saying? Okay, now, just so happens, we can't multiply 6 by anything to get 9 or to get 4. So we know we're not going to be using 6 and 1. Do y'all see what I mean? Now, we can multiply 2 by something to get 4. What would we multiply 2 by to get 4? 2. Can we multiply 3 by something to get 9? By 3. So that tells us that we're going to be using these 2 on the inside, not the 2 on the outside. Do y'all see what I'm talking about? So that gives me 2 times 2 here, 3 times 3 there. Right? So I've got 3x and 2, that's this one. And I've got 2x and 3, that's that one. And then we got to talk about our sign. So this is a positive. And these are positives. So does it make our signs? Since this is positive and these are positives, everything can be positive. Everything's going to be positive. 17? Y'all having me do all the ones I told y'all to do yesterday?
Oh, we don't got time.
It's what time? Oh. All right, let's look at 17 real quick. So on 17, is there any greatest common factor? There's not. So let's do 4 times 3. That's 12. Down here, we're going to put negative 7. What numbers could we multiply that then add up to negative 7? Negative 4 and negative 3. So that gives us this part. Oh, the x and a y, because this middle term's got x and y. Do y'all see that? And then this is 3y squared, and this is 4x squared. So what we know is it could be 4 and it could be 1, or 1 this way and 4 that way, right? Or it could be 2 and 2. Now, can I multiply 2 by anything to get 3? Could I multiply 4 by anything to get 3? Could I multiply 1 by something to get 3? I could multiply it by negative 3. Now, this is an x, so this would have to be negative 3y. Y'all see what I'm saying?
Oh, yeah.
Okay. So that tells me I'm not using the 2. I'm not using the inside numbers. I'm using the outside numbers. What can I multiply 4 by to get negative 4? This is 4x, remember? I don't know why I put that right there. I don't know why I did that. That's 1x. So, what's that got to be? Negative 1y. Do y'all see it? So, I've got 4x minus 3y times 1x minus 1y. That one was hard because of the x and the y. Oh,
I think it's time to go.
I don't care. I'm going to do my